Hello everyone. Today let us start with part B program, that is Floyd-Warshall algorithm. So this Floyd-Warshall algorithm objective is it will find the shortest path between each vertex with the other nodes. Okay. So now first we have here two user-defined function. One is to find the minimum value and one is for function, that is Floyd's. Okay. So let's start with the main function. You have here an array P of 10 just to store the values of the matrix. Okay. N is for number of nodes and I and j are for the looping purpose. First, you are going to enter the number of vertices and you are going to store in a variable called as n. Then you are going to enter the matrix. Okay, so you are going to use the two loops and you are going to scan. You are going to store in a double dimensional array called as P of ij. Finally, you are going to call the function that is plots of Pm. P means here you are passing the double dimensional matrix and n is nothing but the number of vertices. Okay. So now it will be received here. So what it will do, ijk. So here we are taking three local variables again. So k equal to 1, you are going to loop with until end. And then again you are starting with I loop and again with the j loop, all the inner loops. Okay. So if I equal to j, then you are going to initialize it to 0. Why you are going to initialize it to 0? Because consider 1 to 1 or 2 to 2 is the self loop, right? So that's why it is 0. Hence you are going to find the path that is minimum of P of ij comma ik plus kj. So this is same as the matrix multiplication. If you remember, there you were doing the multiplication process, but here you are trying to find the minimum value. Okay. So and here k value remains constant until this particular loop gets completed. Okay. So now what happens whenever you call the minimum function? The function will be traced back to here. A and B are sending the two values. It will check for whichever is lesser and it will be returning the value. Once it gets completed, you are going to print the output matrix. Complete matrix you are printing with the help of two loops. And then finally, you are going to print the shortest path by using the looping again. I equal to j equal to your loop using the same for loops again. Now here, if I is not equal to j, why here we are taking not equal to j? Because if it is equal to means it is self loops again. So if it is not equal only means we need the shortest path. So that's why here you are trying to find the you're trying to print the values, that is ij and P of ij. This P of ij will be traced back from the here, that is the output matrix. Let us assume one example here. So this is your graph which is directed and also it is connected and also it is weighted graph. Okay. So here you are entering the number of vertices. What is my number of vertices here? 4. Matrix, you can see here wherever there is a no path, I am taken as the 999. But wherever the self loop is there, we have given the input as zeros. Okay. Output matrix means final output what you are going to get. You can see here how it got changed. Here you had 999 and here you got as 5. Okay, means there is no path directly from node 1 to 3, but with the help of other nodes you can reach the node 3. That is what here 5 represents. Okay, let me tell you with an example here. You can see here now 1 to 3 you don't have any direct path, but you can reach this with the help of some other nodes. Okay, so how you are reaching? You can see here 1 to 2, that is 3 values is present, and 2 to 3, that is 2 values present. So that is 3 plus 2 is 5. So that's how you got here 5 value. So in the same way, for all the other nodes also, the value will be found. Once again, in Floyd-Warshall, what happens if there is no direct path? It will take the help of the other intermediate nodes and it will try to reach that particular node. So that's why we are having here in the output all the edges. You can see here 1 to 2, 3, 4, 2 to 1, 3, 4, 3 to 1 to 4, and 4 to 1 to 3. Only if it is not equal, it is printing. If it is equal, means it is assumed that it is a self-loop, so the value will be 0. So this is one of the simplest and best algorithm we have to find. We have which finds the also shortest path. Okay, thank you everyone. Yes.